Okay. In theory, the stream is live. Let's see. Chat's still working. Okay, that's good. So now I just have to advertise this. Just gonna send this to all the people I know. So that's me sending it to people I know. Let's see, who else should I send this to? I think that's probably going to be it for now. Let's see, one more place. Where am I supposed to advertise on this website? Let's go to just one more website, which is Watch People Code. Sorry, I know this part's boring. Dun, 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 dun. Okie dokie. So that's me advertising everywhere. You should be able to find the tutorial that I'm going to be following in the bottom of my current post. Let's see here. Yep, so the tutorial should be in the link at the bottom. Put that in the doobly-doo or whatever you want to call it. And now we're actually going to follow that tutorial. First things first, of course, I'm going to use Bazel to run my project. Let's see. So this is the tutorial we're going to be following. See if you have the right one, if you can see this. I'll leave this on the screen for a moment. Those are not my problems. Those are in a library that I have. So I already have a Vulkan project that works. So now basically what I want to do is I want to be able to resize the screen for it. So here's the compilation done, right? So notice that I can't resize this, right? And this is just a shader that's running. Maybe the first thing we should do is change the code so that when we start the program, it shows up on the right screen. And I'm just going to do this the hacky way. I'm going to go into STL. So it's starting it centered, but it's not doing it on the right monitor. So we need to Google how to get STL on a second monitor. So it looks like there's a special version of this macro. So if we go to this macro, yeah, so you can choose what screen to center it on. So it's centered on display 0 by default. So we'll set the my secondary screen. That way it pops up on the stream. We'll have to remember to undo that when we're done. But so, yeah, that worked properly. Good. Okay, so now that you guys get to see it when it's done building, let's look at what we actually need to do here. Second, just rearranging something on my stream. Okay, let's go back to our swap chain recreation. So I've been following this tutorial for, well, I guess 3 months now. It's the 3rd month that I've been following it. And that's where I followed all of these chapters, which some of them are pretty long. I mean, that's actually a lot of stuff, so that I can just put a triangle on the screen. And I modified that shader myself to put the extra triangles on there. Normally it's just the one triangle. So let's see what this says here. I have briefly read through this, but you'll notice that this is actually quite a lot of changes that we have to make. I'm also not following this tutorial exactly. I'm doing it slightly differently because I'm actually putting it in objects and I'm not just using like a single global object. So we're gonna skip this part because I'm already aware of all this. So the first thing is we need to basically separate out our swap chain object, right? So the way that we currently have this, I haven't touched this engine in a few weeks, so I'm gonna have to remember some of this stuff really quick. So yeah, we have a swap chain object. And we have the code for it and the cleanup code. So let's see what we have here. So the things that we need to clean up are the frame buffer, the command buffers, the pipeline layout, the render pass, image view, and then we can destroy the swap chain. So if we look at our primary instance here, we have our takedown function, which actually shuts everything down, which right now this is responsible for cleaning up the frame buffer, command buffer, which are the things that command buffer. The image view, which I think is inside of our frame buffer, is currently how we have it, and the pipelines. So this is the draw function. So what we need to do is we first need to separate out our takedown code that's responsible for the swap chain. So if we come up here, we need to create our new top level functions, right? So we have our configure, our build up, our takedown, and our draw frame, which are all public interfaces. So now we need our private functions. And those are going to go, so public internal functions. And we'll put them here. So we need a cleanup swap chain, and we need a create swap chain. And I'm cheating, but I know that ahead of time we're going to need to pass this the parts of the previous swap chain when we create it. But I'm not sure how I'm going to do that yet, so we're just going to do cleanup swap chain first. So right now there's just this, all my global variables are sort of on this object to an extent, and that's not exactly the best way to do that, but we'll do it this way for now. So we have our functions, come over here, those go, this is the wrong object, sorry. So those would go at the bottom here, above check result. Oops, that's not what I wanted. You'll have to forgive me for being slow with the typing. I'm still getting used to my new setup. Okay, so what we're currently going to do is we're going to call, so these are private functions, so I forgot the underscore. Whoops. So if we come up here, we need our takedown function. Right, and I was using this bool return style, so I don't know if I'm actually going to continue to support that or not, but why is this an error? Okay, well, that just appears to be me forgetting to save this file. No, they're changed. Okay, well, my IntelliSense is bad. Okay, did I manage to misspell this? This is not how soon I expected to have problems. It's a function. Come on. Okay. Thank you. Whatever. So the way we're currently clearing the swap chain is we're basically getting rid of this pointer, but we have to kill the pipeline too. In fact, I'm pretty sure all of these things are necessary to get rid of. It's just going to be unfortunate. These semaphores. So they don't think the semaphores are necessary. So first let's reorganize this function, and then we can put it in our other function. Why is this, what's going on here? Huh. My IntelliSense is not liking something here. It's frustrating. But the semaphores go after, and the command pool does not. So we're going to take our frame buffers, put them up here. So what's going on with these scopes is you can just put a scope in the middle of C++ code. Which text do I need to make larger? This text? That? Or maybe you mean this. I'll make both of them larger. Let's make the console larger. Okay, that's probably about as big as I can go. So these scopes are, I mean, it says it right here, right? Region to make sure the shared pointers are destructed. But so with C++, destructors are run when an object falls out of scope, and I'm creating temporaries here. I'm not sure if it's actually strictly necessary, but I'm really just trying to, I'm going to restart my IntelliSense. It's not strictly speaking necessary, but it's basically me just hoping that I don't think it's necessary, but I'm just trying to make sure that it's for my own safety of mind. But in theory, if I had a temporary in here somewhere, this will ensure that they'll get destructed. So by the time I get here, they'll actually get deleted. Because there's some semaphores and other things going on in here. So pipeline swap chain, frame buffers. What else did we need to get rid of? Frame buffer, command buffers, the pipelines, render pass, and the image views. So not the semaphores. Command buffers. What a frame, command, pipeline. Frame, command, pipeline. Swap chain. Okay, now we're going to take this. I don't. It seems to just, wherever I edit code, it seems to just be making errors. So I don't know if that's even really useful at this point. Like, is there like an error in this file or something? Whatever. Okay. No. Okay. Seems to have. I'll take incompatible. That's better. I'm just making sure I didn't miss anything obvious and why that's unhappy with me. Okay. So let's make sure we didn't break anything. Okay, so if I close this, no errors. Okay, so everything's still shutting down properly. So we've now moved all of the relevant code. This surface, I think we might also have to recreate, but I'm not sure yet. We'll see. Okay, back to the tutorial. So let's see what we got here. So Vulkan apparently provides this information about whether a subchain is suboptimal or not. And I think I've kind of handled this part. But this basically is a, if sometime during the rendering these things go out of date, we need to recreate it. So the way that you would traditionally handle this is that you would, and I think this is what we get into down here, where there's a callback that says, hey, the thing got resized and you need to recreate the swap chain. But this is sort of a backup, like a just in case that didn't go correctly, then this will catch the error in the middle of rendering and do it. So if we go to our renderer, so this is our creation, and then draw frames after this. Okay, so draw frame. So it was near the end, right? Present queue, or acquire next image. Okay, so we go to acquire next image. So yes, I've already done this. except for I've done the to-do actually rebuild. So we're probably gonna do, for now, we'll do a bool. I'm thinking this is actually going to end up taking arguments to tell it what kind of, what the previous swap chain was so that it can know how to recreate it properly, but we'll see for now. And that way I can reuse this for the creation code as well, because I like reusing code. So and then there's also a queue. So they return this frame, right? And that's the other thing, is the not guaranteed to happen part here. Let's see. So they call create swap chain and then they return immediately, so they skip a frame. That's what this is looking like. I'm not sure if I agree with that, but we'll do that for now. So they do it at the end here as well. Okay, so see what they're doing is with the suboptimal ones, they continue with the frame. So if it's out of date, you can't use it, right? This is an error. So they recreate it and then they skip a frame. But if it's merely suboptimal, they continue with the rendering of the frame. And then when they get to the end here, and if it's still suboptimal, then they recreate it at the end. So by the next frame, it'll be ready. That does sound probably about the correct way to do it, actually. So let me set that up that way. I agree with that. So this is here. We already have a break for this. We already have a case statement for this, I mean. So what was I doing here? Okay, this is not, none of this is good. So this default is to do this. So that check result macro prints out all the different errors and stuff. So I kind of want to keep it in the line of what we're doing here. Actually, I guess I can just do this. I should probably indent that. Okay, whatever. Then if it's suboptimal, we log that it's suboptimal and we continue with the render. And if it's out of date, then we log that it's out of date. We recreate the swap chain and we return. just don't like any of the possible code styling options here. Fine, we're doing it this way. Okay. And then we're going to take one of these, and we're going to go down to the submit, and we're going to do the same thing. We're going to replace what's currently here, something that breaks out the result codes. Yeah. Okay, so if it's out of date, if it's suboptimal, we also do that. And we want to continue running because we want to hit the timing information here. Are we inside the timer here? No, timing starts there. And then we don't need this anymore. We don't need this. Okay, so we now match this code. So this is the backup code where if something goes wrong and we don't get like a notification from the operating system or whatever, or, I mean, we're doing it on both ends basically, right? But if these don't get triggered properly, if the operating system doesn't send the message properly, then we'll use these. And if these don't get sent properly, then we'll have the operating system to back it up. So let's make sure everything still runs. And then we can go screw around with our operating system layer so that it actually lets us resize the windows. Oh, all right, I had an error. This is GLM stuff, which we don't care about. I should probably fix that, but that's depreciated in C++20, so I don't care. Oh, whoops. So you can't give default arguments in your definitions. So function doesn't actually do anything at the moment, right? Okay, so it still starts up, still runs. I can still close it, no errors. Okay, great. Let's put a log message in here. Whoops. Okay. And it'll let us know if it actually gets called. We'll delete this later. But that's just for now. So we come back to our tutorial. Let's see. So now we have to deal with, make sure I didn't miss anything here. Clean up. Okay, so they actually do have stuff in recreate Swapchain already, which is these steps here. I thought I might have missed something. Okay, well, we can do this. Do they actually use that to create their Swapchain? No, they've packaged it this way. Okay, well, we may actually have to end up refactoring some code, but hopefully not too much. So the first thing is we want a VK device weight. So this is a weight for fences. I don't think I have anything that's a device weight. Let's find out. Oh, I am gonna not enjoy not having IntelliSense. Do it the old-fashioned way. So we can add a weight function on here. And it's going to be at the bottom. Sure, that is weight idle, right? Yeah. What did I call it? I had a naming style that I've now forgotten. Is it just, yeah, it's just value. Because that's the value that we're currently in. Okay. It's a very tiny function, but it lets me do that, which looks nice. And then we have to create the swap chain, image views, render paths, graphics, buffers, command buffers. Okay, let's find out what part of the code in our creation code all of that is. So we build this all up on the first time, and I think we ended up doing it in a slightly different order. So swap chain, right? So here's where we make the swap chain. So we're going to cut that, and we're going to put the recreate in its place. This IntelliSense thing is killing me. Right, I'm not going insane. I have a, it's called create swap chain. Create swap chain. Okay. Whatever. It's frustrating because this was working this morning. I don't know what went wrong. I don't really want to spend a bunch of time figuring it out. So I'll just deal with it. I'll have it ready for the next stream. Okay. So we recreated the swap chain. Recreate the image views. Pipeline's on the list, right? It is. Where did we create the image views, though? Probably in the frame buffer here, right? To do refactor below. Well, I'm doing that now. Like, okay, so that's just the IntelliSense. Trying to see if I can fix this. Like, it's just, the source code it's quoting is just wrong, so I don't, like, that's not what's there. Is there... I said I wasn't going to do this, but now I want to go do this. Well, that looks like the problem right there. Okay, well, I'm going to try restarting this visual code really quick. Okay, seems to have booted correctly that time. That's fine. If this was that trailing comma, I'm going to be upset. Okay. I have IntelliSense again. So let's go back to our tutorial. So we need to go find out where the image views are, which I forget. So if I look over here, image views, swap chain image views. Right, okay, so the image views are actually on the swap chain. I remember this now. So if I come over here, I put these on the, yes, here are the image views. Images, image Vulkan image base, and I store the images here. So swap chain Vulkan image. So they're on the swap chain itself. Okay, I did it object-oriented, and I forgot that I did it that way. Great. So that's the image views ham. So then we need our render pass. And I think that my render pass, pipeline, I think I put my render pass on my pipeline. So let's go look at that, because I did that object-oriented too. Let's see. Configure, viewport, pipe, blends, dynamic states, color attachments, render pass. Yes, okay. So that's on my graphics pipeline. So then these two are, if I recreate the pipeline, which is this, put that here. Yeah. And then, okay, we're entering the part where I haven't refactored it yet into something object-oriented, the frame buffers and the command buffers. So these are my frame buffers, and these are my commands buffers. Great. That's great. Okay, so setup drawing here is the semaphores and the code fences, which I don't think, if I look here, the previous code, so yeah, semaphores are in their own group. And the command buffers and the command pools are two separate things. Okay. So semaphores. So we don't want to recreate our command pools, which I don't think are actually being created here. Yeah, okay, so we can copy our command buffers and our frame buffers. And these all go into our create swap chain function. Reference error, though, is this vert and fragment shaders, which I was creating above. Did I break IntelliSense again? I think I broke IntelliSense again. We'll see if it catches up. Yeah, to do move to asset subsystem. Well, I can put that in the swap chain. Well, really, I don't need to recreate these, right? So what we're going to do is promote these to object variables, which will solve the problem. It's getting there. I'm curious what there was a, never mind. Maybe it doesn't like this. It's possible that this isn't properly defined. No, I found it. It's in the right spot. Okay, well. Well, we'll see if it compiles. So in theory, that should be everything. So we're just moving around code right now. I've tried reloading it. I mean, I just tried restarting the whole thing. Okay, so there is actually an error here, it looks like. Oh, because I pulled the, yeah, this, which I don't want. So that's why it's above that refactor mark. So we're going to have to come up here. And this code here uses it. Okay. Right. So I use this, I've been using this paradigm of returning true or false if things go good. So we're going to have this return. It's going to return true at the end. I think we're actually going to keep that. So far we haven't actually changed the behavior of this depending on whether it's a recreation or not. But I am going to just print out if it's a recreation. So we can keep track of when things are getting recreated. If I can spell, yeah, okay, it's just tell sense. And then I actually need to use that properly. Change this. Hey, so it's still working, which is nice. You notice the FPS here. I mean, I'm not really changing anything, and I can't even resize this window yet. So let's see if it shuts down. Shuts down. Great. Okay. So now that we've rearranged everything, I think I'm actually going to make a commit here. I don't know if I actually changed those settings. Okay. Well, whatever. I remember what this file is now. Anything else we don't actually want to commit? No, that all looks fine. Refactoring, swapchain, creation, code. Really? Because I wanted to do that. I don't have to push it yet. Okay. So now we're actually going to make it so we can rearrange our window. Handling memos. So here, handling resizes explicitly. So I'm going to skip this bit for the moment because they're kind of getting ahead. Instead, I'm going to come down here and actually do the step where I make it resizable so that we can see how well our backup code that we just wrote or whatever. The code, I mean, theoretically, you're supposed to be able to just do this and not have to worry about your OS subsystem, but apparently you're supposed to do both if you want something that's like, you know, reliable. So I'm going to do both. So the tutorial uses GLFW. I do not. I use SDL. So we're going to go to our platform here. It's very minimal. We're going to come back here. We're going to create a resizable window. So if I look here, it's probably the flags. I should probably just Google this, but it's probably near this. Resizable. This is the one we want. So now we can resize our window and break things, is the hope here. And in theory, the code that we already have should fix it. So let's see what happens. Okay, well, that's she is we're gonna go with that's the function's getting called, so that's nice. It's not fixing the rendering, which is not. It's apparently still rendering though, so I don't know what's going on there. In theory, if it's recreating the swap chain, it should be assigning it into the variables, right? So it should be rendering with the new swap chain, right? So see if I can somehow figure that out. If I make it really tiny, does the FPS go up? No, it appears there's a memory leak because the FPS has gone down now. So if I create this big, yeah, I think every time I'm recreating these, I don't think I'm cleaning up the old ones properly. Oh, there we go. Resource temporarily available. I think I ran out of swap chains. So I'm not cleaning up the old ones. So I have some sort of memory leak going on. And it's possible that they're all rendering. That would be my current guess of where I am. So if we look here, create the swap chain in our draw frame function. We are creating a new swap chain, right? With swap chain create true to say recreate a swap chain. We come down here. We wait for the primary device, which is why we're not getting any sort of crashing, so that's nice. And theoretically, we're assigning into all these variables, right? We're clearing the smart pointers here, and we're resizing them to the new sizes. So that should be freeing up the old resources. It's possible that I'm not deleting. Oh, I'm not deleting them. That's right. Okay, so right, clean up swap chain here, right? I'm not freeing the command buffers or the frame buffers. So this is probably what's causing X to not like me. So right, if we're in recreate, we have to clean up the old ones first. Probably need to do that after waiting for the device. Okay, so now in theory, we should not get, X should no longer get angry at us. go. Okay. X is still getting angry at us. I'm curious what this error is. Resource temporarily unavailable. I'm curious what this error is. I don't know if I would call it pretty intuitive. I mean, these are my helpers, to be clear. So for example, if I go to the Swapchain helper, right, so this is my wrapper around it, and then if I go to the code for it, like I'm actually like creating all the stuff. Like this is what Vulkan looks like create a structure, put stuff in it, create a structure, put stuff in it. I'm sorry, the one that I wanted to show that is a scream is this pipeline creation. I mean, it's only 250 lines long, but it's just like, this is how I create a pipeline. You have to go through all of this stuff. I mean, it took me a while to like go through all of these things. And like sometimes you have to like go out to other like features. There's like a lot of like interdependencies going on. So like coming up with a mental framework for your project is a big part of using it. But I want to find out what this error is really quick. I don't know if I want to fix it necessarily, but one of the ways that I like to work on this is find something that breaks and then fixing it, because then I'll know what that problem is before I get it later when my code is more complicated. So I'm not going to show me Googling for this error because I don't like showing. It's just, I like to do that off stream. So let's see, XIO fatal error 11. Resource temporarily unavailable. Let's see what that is. You can Google along with me. Red Hat is doing the Microsoft thing where they find various bugs that people have, and they're like, here's what this error means. So that's nice. Okay, I just want to know what this error is here. Let's see. See. Well, it appears that this is just you close the window improperly, which might be related to like a swap chain timing out or something. I'm going to move on because I don't really want to delve into the internals of X right now, and I know that I'm probably not doing things correctly. But I think the first thing I want to fix is this. It's possible that it's also just me holding this down for a really long time that's causing that X error. So let's see if I can cause it. So, I mean, like the FPS is going down, right? Like the more that I do this, so there's definitely some sort of resource leak. Oh, there we go. Okay, so it's saying that there's 202,000 failed requests, maybe? Okay, so it seems like I'm not pumping my OS properly here for events, or I am, and I'm not handling them properly. Like SDL has a loop. It's pulling events. So I mean, this should be running, right? I kind of almost just, this is going to spam so much, but I just want to make sure that, come on, IntelliSense. Whatever. I just want to make sure that my event loop is running, because that seems suspicious to me. It's probably because I'm not handling the resize event properly in some way. But I guess the program's not behaving the way that I expect, and so I'm just curious to find out why. Okay, so I'm handling events. Good. Okay, well, I give up then. We'll move on. So the next step then, now that we have a resizable window, is to figure out why it's rendering the way it is. Right? So what's odd to me is that when I drag this out, we get this effect here, right? So I'm assuming that this is still rendering because I'm getting these messages. And I don't really have a way to check whether this is rendering or not because I can't put like a time value into it yet. That's later in this tutorial. But I'm assuming that but this should be rendering across the whole screen, right? So this isn't bound to the size of my, like the pixels of my thing. It's bound to the size of the viewport. So it should be rendering across the whole thing. So I want to figure out what's causing this effect. And I suspect that it's when I'm recreating my swap chains, assuming that I'm doing that correctly. When I'm recreating them, I'm not using the correct size information. So the first thing I'm going to try to do is use the correct size information. So the frame buffers use the swap chain VK extent. So let's go find out where the swap chain is getting its information from. So we have swap chain VK extent here, which is the select extent. So that comes from the creation code, I'm assuming, right? So if I go to my create function, where are we getting this extent from? So the selected extent. We are getting it from get drawable size of Vulkan. So the first question I have is SDL giving us the right numbers, right? Let's see if I can do this without. There we go. So let's see if SDL is lying to us. It's possible SDL is not getting the resize event for some reason, and that's why X is also mad at us. So that's just what I'm curious about here. Our event's not getting called. Okay. Well, our event's not getting called. Right? We are recreating a swap chain here, right? So we clean up the swap chain. Swap chain called for recreation. Clean up swap chain, which deletes that object, right? Yeah, so it gets rid of that smart pointer. So we make a new one, and we call create on it. We're not getting an error. Apparently I'm supposed to call it like that, but whatever. We're not getting an error. Oh, because that's a const? I don't understand what's... Sometimes I do things and I don't remember why I did them, but whatever. So this function's getting called. If surface current extent.width is not. Oh, okay. So it's asking the surface. Okay, so there's our problem here. Is it's actually copying this extent here. Okay, so then is the surface lying to us? And where is the surface getting its information? So it's getting its information from Vulkan. Yep. Is that actually an error? Oh, because, okay, the function I'm calling it from is const. Okay, so now if I resize this. Okay, so there's our problem. The surface is lying to the swapchain creation function. So if we go to, let's see, swapchain, so the surface. So it's being created with STL, but where's its extent coming from? Query support. So it's coming from supported capabilities. Supported capabilities, when is this called? It's not called on create. It's called on set device. So is the surface is not getting, I think this is in a function here because we do need to recall this when the device is manipulated. So let's go look at our creation sequence, right? So creation of the frame buffer. So we're not actually even recreating the surface here, right? So we need to tell the surface that something is up. How did they handle this in the tutorial? Because I'm following the tutorial for a reason. I am using the Vulkan validation layer. In fact, when I start it up, you can see this. So it's not actually supposed to be printing this crap out. It only does this on Linux, where it's setting the validation for these device extensions to be info instead of debug. If I ran this on Windows, most of this validation stuff would not be printing out. Because I'm respecting their log levels, and I probably shouldn't because on Linux they're printing out a bunch of information instead of when they should be printing it out as debug, but whatever. That's a them problem that I don't really want to bother fixing. So yeah, I'm not doing anything wrong as far as Vulkan's concerned, right? I mean, I'm just using, what I'm saying to Vulkan is saying I only want to draw on the upper left 640 by 480 of the screen. There's nothing wrong with that. It's just that it's not doing the behavior that I expect. So how do they handle this here, right? Because in recreate swapchain, right, you would think that, so it's maybe what happened here is that in create swapchain, they're doing something I don't expect. See, this is like almost literate programming, which is annoying. Let's see. So, okay, yeah, so they actually do query. But they don't. They just pull straight from the capabilities. Do they update the capabilities in here? They don't. Okay, well, I'm going to call that function again. And if that's expensive, then I'll have to refactor that later. But so I need to update these. I was forward thinking and I put them in a function here. The Vulkan swap chain's already a friend. you know, to do have no friends. But so here, before we do this, we do a surface query support. And then that should give us the right numbers. Put back our log here. And this is the expected behavior, right? Is when I move this, the thing that I'm rendering resizes. Oh, come on. Okay, so it's still doing that. And I think that's a cleanup error. And I think that's what the next part of this tutorial might deal with, right? But if I make that, it changes the size of what we're rendering. So that's good. That's working as expected. Besides the memory leak. I don't even think it's a memory leak. It's a resource leak, I suspect. A Vulkan resource leak. Let's see. Add another commit there. Resizing windows works correctly. Or making, you know, that present progressive. You see how I just almost have that instinct to always push. We're going to put a note here to do performance, avoid calling here. Okay. So we can go back. Sorry. Just wanted to amend that commit, so I put that comment in there with it. Okay. So now we need to actually add a callback on resize. So we get to have fun with the callback system and whatnot. So SDL. So SDL does not do a callback system by default. It might have that now, but that's not how I'm used to using it. Instead, we need to look for an event. If event type equals some sort of window SDL. It's going to be SDL underscore, right? Yeah, window event. I'm assuming that's resized. There we go. Now we need to figure out which of these datas is which. So it's time to go off to the SDL documentation. From the SDL wiki. Okay, apparently I'm supposed to use window event size changed instead of resized. I should probably use a case statement and stuff like that in the future, but whatever. We can use this for now. You know, I don't think I actually even want to bother with this information, but I'm going to extract it anyways because I might as well. What is this stored? Signed int. Okay. And this is SDL window event. Size changed apparently. then we don't have, I'm not using an independent window abstraction, as it says here, to do abstract. So we're going to add a lot of this code is not ideal, because the idea is I want to get the Vulkan part working, and once I have a good understanding of how all the parts work, I'll separate out things. That's not an excuse not to have an abstraction around the SDL window, but yeah, I'm going to use it as one. Sure. Okay, good. That does exist. It's just IntelliSense again. So we have our event now. It's on our SDL subsystem, and our Vulkan subsystem requires this. All right, so we go here. We have our SDL manager. So this is where the event lives. And so now when we get that event, which is going to be at the top here, build up. So yeah, so here we're attaching this draw frame function. So this is a good point to this in here. I mean, in theory, we just call recreate swap chain, right? Let's see what they're doing. I need to put this observer somewhere though. Okay. So we don't want to call this. Let's see what they want us to call. Frame buffer resize callback. So they do take the width and height. So we'll see if we want that. Oh, that's because they have to, because of the callback. Let's see here. So they just set a flag. Right? How were they? They were in the draw frame function. Okay, that's fine. It's simple enough. So we create a state variable. Probably here. Use new swap chains. Easy peasy. Of course, we have to actually go use it. I think at the end of this, we can set the variable to true or false. We can clear it. And here is where we need to check it. Of course, here we're using a switch, and they're using an if statement, so it's not that easy. Is it bad that I want to use a goto for this? Probably, right? So one thing I just noticed is that this, I think what we're going to do here is we're going to do this instead. We don't need this because we have that in the recreate function. Needs new swap chains equals true. And we can put this after the timing so it doesn't get stuck in our timing numbers. And then we do a in theory, we could probably do this up here too, and then that way, when this happens, we can just skip all this, but I'll refactor this later. Okay. So in theory, that should all function. Just trying to see if I forgot anything. We're going to change this to say great. So in theory, this should all work in a moment here, because there's not any more after this. Then we're moving on to the next step. But for some reason, I don't think that I don't think that's going to fix the X bug that I'm having. So we may skip ahead a little bit in the tutorial to the next half of this swap chain recreation system. The next half is recreating the swap chains in an efficient manner so that you keep the frames that you were in the middle of compiling or drawing. I forgot a semicolon. Of course I forgot a semicolon. It's not a programming stream if you don't forget a semicolon at some point. Okay, well, I left that event in there, which is fine. Okay, so I mean that works. I wonder if it's getting it from the event or not, right? Because it's using those KHR detections, and then we get this. Okay, well, let's remove some of the spam. Inside the swap chain, we're printing this. We don't need to print that anymore. And then we have to go deal with this resource leak. I think it's a resource leak. It could be a couple other things. That is an expression. I don't. So that was one piece of the spam. What was the other piece of spam? Swap chain out of date rebuilding. Okay, so this is saying. This means that it's hitting the KHR part, right? So like this is this one here. So it's here. So that means that the SDL one, this one is not even getting used. Is that what that's telling me? For good measure, we can print out width and height. So that SDL event's not even firing. Okay, well, great. It doesn't do anything, huh? So let's try resize then. Oh, whoops. What am I doing wrong here? I mean, I could turn this into a giant while loop or whatever, but I don't. I mean, main loop is getting called, so this outer loop is running. This inner loop is running. We checked that earlier. Okay, let's try this. I think I know what I screwed up. Is there... See, that's what I screwed up. Okay. It's there's multiple types of events in here. So it's this event window dot event, because that makes sense. This is what it's supposed to be, right? Because it's a descending hierarchy of unions. Okay, let's try that. So I mean, it runs fine if I don't resize it, right? Like it's got to be a resource leak when I recreate the swap chains. So if okay, so we're getting the resize events now. Of course, now it's calling recreating swap chains multiple times, right? Because it changes the window and it gets called twice. Because it gets called once because the render loop comes around and hits it and sees that, hey, it's out of date. And then it leaves the render loop, or some other time the SDL loop runs, and then it hits it. So that's something that needs to get fixed, because that's not how that should be working. So I'm going to put a note about that. Right, so, well, right now the duplication is happening in here. I mean, technically this is where the problem is, but that's actually the right code, so I'm going to put the note up here. Because that way, if they both trigger, we don't actually want to recreate the swap chains multiple times. But that's a later problem. For now, this is fine. So now we need to figure out the. I'm going to remove that SDL problem here. We don't actually need to record that. This isn't being used for anything, but in theory, I think I have. No, those are the original windows and heights, width and height. That's not the current width and height. So let's add a current width and height, and we'll keep that up to date. Don't need default values because they'll keep getting assigned. So we'll create these and we'll update them. So when we create it here, actually, let's just do it this way. No, let's, yes, we'll do it this way. because later these are going to get pulled from like a config file or something, right? Did I misspell it, or is this just IntelliSense being bad? Yeah, it's just IntelliSense being bad. Okay, whatever. And then this can be... Great. So this tutorial talks about dealing with minimize next. But I'm not sure if that's the right next step here. Let's see. So the next part would be, because this is the swap chain recreation part, but the next thing is in vertex buffers and stuff like this. I don't want to get to this stuff yet. That's going to be probably tomorrow or something. There was somewhere else on this website about dealing with passing the old swap chain into the new swap chain that he talked about, and I'm not seeing it. And maybe I just skipped over it because I was moving so fast. But there's a way to pass them into each other, which would neatly solve what I think is the resource issue and the in doing this tutorial. But he doesn't talk about it. I'm not seeing it right now. Maybe it's in the swap chain chapter. I mean, so the next step is to figure out where my resource leak is. Right here, right? Create info, old swap chain. And this leads us back to this chapter, where he doesn't actually set that variable. Right? No, here it is. It is possible to create a new swap chain while drawing commands on an image from the old swap chain are still in flight. You need to pass this previous swap chain to the old swap chain field. But he doesn't do that. Okay, I understand now. So he doesn't do this optimally. So maybe that'll be what we do next once we fix our resource leak here. So let's turn on. So somebody. Sander, who makes the wonderful ECS library FLECS, or Fleeks, pointed out the validation layer. And so I'm going to have to... It's possible the validation layer will tell me what I'm doing wrong. So I'm going to go turn that on really quick, and we'll see if it gives us anything useful. And that's going to be our first step of finding our resource issues, which is this command here. I need to make a command line argument for that at some point, but I need to add a command line parser first. So in theory, we should have gotten additional validation information. It looks like we didn't, which is worrying. I might set that to debug. Yeah, I don't know what that is. So this should be setting... Right, we're not using this anymore because I added a fancy feature which is logging get engine logger, right? Yeah, get engine logger. Okay, so I added a fancy feature where I actually create the loggers so that I have more control over them. And as a consequence, I have to change that somewhere else now. Where do I change that? Read your own code. Get managing logger. Get engine. Right. There's a subsystem for that now. Right. I was going to do configuration next at one point, and then I didn't do that. Okay. Well. Right. Oh, that's okay. So we're always logging debug now. I remember this. Okay. Let's see if I can remember how to do this. So in here, there's a folder called logs. What's in logs? Right. So it's the one that doesn't have the name on it. I was thinking ahead here. So this was the last run that we did. Right. So this is all the debugging information, and Vulkan spits out a significant amount, right? Like, there's the page down button. Okay, so if we go all the way to the end here, well, I expected something from the validation layer. So this is the validation layer. Flex. It's flex, like flexing your muscles. Is that what you're saying? That's fair. That's probably a better way to say it. But like fleek is, you know, that's what the young people are saying for some reason. I don't know. Okay, so I'm getting debug information. There's just the validation layer has nothing useful to say to me. Okay, so validation layer doesn't have any hints. Let's see if we can get the IntelliSense. Oh, it just went. I was like, let's see if we can get the IntelliSense, and then it changed. And it's like, oh, yep, see, everything's happy. Everything's kosher here. It's finally happy with me for some reason. There. Oh, my IntelliSense got fixed. Great. So now comes the hard part of weird flex. Yeah, that's a good way to put it. So now the hard part of figuring out resource issues is we have to figure out what resource it is. I think that's the first part. So X is maybe telling us, so is this thing we're getting from X, is this consistent? Are we usually getting the same error? Okay. We are now usually getting the same error. It's not what we were getting before. So let's Google that really quick, see if we get some better information. So this is supposed to be a thing. So I'm assuming this is probably Vulkan, because it's supposed to say like GLX or something. So it's the major opcode is probably saying Vulkan, and the minor opcode is probably telling us what the specific error is. Let's see if we narrow this down. Sorry, I'm not showing you guys my Googling. I guess I probably could. Okay, this is me Googling. Let's see. So it is definitely something that's wrong with our renderer, right? Because these errors right there. Okay, this is not really relevant. at some point, if I look at this enough, I'll hopefully get... I think what I'm going to have to do is read through the code and figure it out. Because I would expect, I mean, I have error code on all this stuff, right? Like if what I would expect to happen is that it would say something like, I couldn't make you a new surface or something, right? Because if we look at the creation code for things like the swap chain, right? I have put guards on all of this, right? So any of the functions that could possibly fail should be printing out an error, right? Like unable, I mean, this error, unable to create swap chain, but it should be printing out an error, even if that error is wrong. But yeah, so from selected device, I got the function name right, so that's the important part. So yeah, this should be printing out an error of some kind, right? It's possible that the error is here, maybe. But I don't, let me look, let's see if it tells me here. No, but I think if I Google this function, it'll tell me that the only valid error codes are something like, index out of range. So that's probably why I didn't put anything on them. Let's see here. Yeah, so it's just telling me that the only possible outputs are that I'm out of memory on my device. Because it's already created these, right? It's not creating these when I call this. This is just a lookup function. But maybe I should put an error check on there anyways. I don't think that's it. I mean, I could put it there. I mean, the thing with this sort of kind of resource leak is what I really need to do now is just go through all of these things and make sure that I have all my destructors are right. I'm actually calling all of them. I mean, I don't call the one swap chain, only the one create function here. There's no other create functions here, right? So it's probably not the swap chain. What else am I remaking? This is just a lot of me reading code now. Frame buffers, command buffers, pipeline, swap chain, pipeline, frame buffers, command buffers. Okay, allocate command buffers. And this has a VK free command buffers, VK destroy frame buffer. Okay, create frame buffer. Well, the first step we can do is we can go be paranoid. Let's see if these swap chain destructors are actually being called. It's always fun to question, the basics. Let's find out. Well, I guess it's good to be paranoid. Why is that? So this was probably a stupid way to write this code in the first place. But I didn't put that in there, so it's not that. That's the issue. This destructor's not being called. And that's our resource leak. I know that somebody in the chat, Sander, has an issue with smart pointers, I think. Or maybe it's just somebody in the Flex Discord that has an issue with smart pointers. Of course, right now I'm being bitten by them, so... Destroy the frame buffers, destroy the command buffers. I can assume those are being ran. So here's the issue, I bet, is that these probably are referencing each other somehow, which is a bad. Aha. There's our problem. Yep, we have a cycle. There's our resource leak. So what's this to do about actually using a viewport? Let's find out what that is about. Okay, well, okay, so it's trying to get the extent out of there. That appears to be the primary usage here. Let's see if there's anything else of note. And it keeps getting the format out of there. Okay. So I think if we do this to do, we won't have a cycle anymore. There's some other things that we can do to prevent cycles in this case, and I think as a precaution, I'm also going to do that. So one of the things that we can do is called destroying. Relying on destructors to release the Vulkan resources was always probably a bit of a bad idea. But this kind of just confirms it. Actually, we're going to keep this warning so that we know that we actually successfully got rid of our cycle later. So this swap chain has a pipeline somewhere, right? Also this set of, we own this though. This is local to us. But we can get rid of that too, because those are going to get invalidated at the same time anyways. Is there not a pipeline on here? Is this not a cycle? Was I being a crazy person? Well, let's fix this anyways. You know, named destroy functions instead of destructors is probably for the best anyways. So these images are Vulkan surfaces, right? So these take the swap chain in. Do they take the swap chain in as an argument? They better not, because that would be a cycle. These are the dangers of smart pointers. No, I'm sorry, I'm looking at the wrong thing. This. Vulkan image. I bet this does take in a swap chain, and that's our cycle. It is. This is our cycle here. Okay. We had more than one possible cycle. So this needs to be invalidated anyways, because when the swap chain goes away, this image goes away anyways. Yeah. I think the other thing that needs to happen here is that this needs to be a friend of the swap chain so that this works correctly. And then we can take these functions, put them in a private section. Probably need to invalidate this image view as well, but that'll get called when the destructor is called. I think if the underlying image goes away, this image view has some behaviors that ensure that it doesn't crash anyways. So I think it's kind of the point of having this. So we'll come to that bridge when we get there. So now this is configure. And now here we can and then clear the images. So that should be our cycle. So that should just fix it. But we'll probably want to clean up some things anyways after this works. Okay, so we have about, 10,000 frames per second. So if our leak is fixed, well, first of all, our leak's not fixed because we should be seeing the warnings. Right, that's because we didn't actually call our new destroy function. Right, so here we actually need to call destroy on the swap chain and not just get rid of the pointer. And then we're going to want to go through our pipeline and our other objects and add destroy functions for them as well. Okay, so let's see if the destructor runs. Okay, so we're actually getting our destructor is actually running now. So in theory, our frame rate should stay at 10,000, even if I do this a bunch. And I just sit here and just do this constantly. Okay, we are now releasing resources. We don't have a memory leak anymore. We don't have a resource leak anymore. I'm going to call that good. I'm going to get rid of that warning message, though. It's not very useful. It's just telling you, hey, you deleted the thing you're supposed to delete. So now comes the fun part of dispose methods in C#, right? Like, I don't think the destructor is going to get called without this getting called first, but we should probably make sure that this is called first if we hit the destructor, right? So now we have to do this back and forth, who's calling the destructor thing. And I don't know if anybody here cares or is aware of the dispose pattern in C#, but it's kind of really annoying. So now I'm sitting here thinking if there's a way I can get around that. One solution is to, I mean, the thing is, the problem with the dispose pattern is that you end up with like 3 functions to just have one chunk of code that does the thing. I guess the thing that we can do here, first of all, this method of detecting whether we ran successfully or not is maybe not a good one. Thanks, Sandra. I'll see you later. Thanks for hanging out. But we're going to keep using it anyways. And I can refactor that some other time. So we're going to set this to this. So this will no longer trigger. And because this and this, we'll put this here. So it clears. So now this function is basically sort of idempotent. So no matter what order you call it in, it should always do the things it's supposed to do. So we can now call this destroy from here. And that way we preserve the, the resource acquisition is initialization sort of paradigm a little bit, where if you acquire one of these swap chains and then you let it go, you don't necessarily have to call destroy. But the way it's currently set up, if you don't call destroy, it's probably not going to destroy itself because you'll have these images laying around. What we should also probably do, now that we've done this, is we should probably also go to this swap chain image and do what we should have done from the beginning and use a weak pointer. So we're going to change that to a reference to a shared pointer. And we're going to change this to a weak pointer to prevent the cycle in the first place. The only problem with this is this thing here. So we'll have to make sure that we recreate this properly. And we should be able to do that if I Google my C++ really quick. Shared pointer from weak pointer. I'm trying to remember what the convention is for casting weak pointers back into shared pointers. Let's see. Let's see here, shared pointer from weak pointer. Okay, well, let's actually just try this. If we just do this, does this just work? If I change this signature in here? Because it's possible this just works, and I'm just forgetting that you could just assign these things properly. I suspect I'm going to get a compile error on the returning of a weak pointer as a shared pointer. Yeah, I did. Okay. Let's try the obvious one. Let's see if it just takes this. I don't think it's going to take this. But if it does, then I can go find the correct cast for this. Okay, well, it did take it, but then we got a seg fault. So I'm going to call that a returning reference to temporary. Oh, well, there's the issue. We're returning the reference to the temporary. That's not what we need to do. Because before we had this as a variable, and now we don't. So now it actually has to get instantiated as one. In theory, though, that means actually this should just cast. We don't need the cast in here anymore. So let's see if we can do it with a cast, actually. I know this is possible. I think I'm forgetting a step here that's important. Okay, it was just you have to cast it. Sure. So no more resource deprivation, no resource leaks. I can do this all day, hopefully. Yeah, okay, nice. So we fixed our problem. And I can do this all the time and keep my 10,000 frames per second. Okay, maybe not the full 10,000 the whole time, but close. Okay, well, that's a done. That's a done recreating our swap chains without breaking anything. So now we can go and do some of the other features that the tutorial mentioned. Uh-oh. Yeah, no, that's correct. Sorry. I thought I had done an amend instead. Not ECS time yet, unfortunately. That's probably going to not be for another week or two. I mean, I have to get through vertex buffers and uniform buffers at the very least before I can do an ECS. I'm still on drawing a triangle, which I now have working. I can now resize the window that the triangle is in, but I have to clean up this code some more. So let's see, if you'll excuse me a second, I'm going to go check something really quick. Okay. So one of the ways that we fixed our cyclic issue here is that we introduced these new destroy methods. We made them idempotent, and we called them in the destructor. So I'm going to go through the destructors of some of these other ones, and I'm going to add that paradigm so that we get, oh, okay, that's weird. What's going on here? Maybe not all of them. I think the pipeline was the other one I wanted to do because we want to, yeah, so these are going to be void methods. So pipeline, because we wanted to make sure that we don't get any cycles, and this was the other one that had a potential cycle in it. I need to spell destroy correctly. Okay, good. So we're going to come down here. I'm going to put our destroy down here. We're going to go to the top. top of this function. It's a very long function. And then we're going to grab the current destruction code. We're going to call destroy. So now we have to set these to null after doing this so that this code is independent. And then we need to, these are not real errors if you're just joining me. These are, my IntelliSense does not like me. And so it's taking a very long time to update things. And then the other thing is we need to make sure we clear the smart pointers on here. So this viewport, quote unquote, needs to be cleared. Everything else should get destructed automatically. I don't think the device, we need to really worry about getting rid of that smart pointer, but I will just because I can. Okay, and then we'll come over here to the swap chain. This also has a reference to the device. What else is a reference to? This is a reference to the surface. We can get rid of those smart pointers. There's no other vectors of smart pointers we need to worry about. Okay, and then we can come back to the graphics engine. We can call destroy this. So we're just doing some code hygiene right now. Just making sure that we don't get, resource problems in the future by making sure that we deal with them now. So we added a pipeline destroy. Okay. Let's make sure that our code's actually compiling properly because our IntelliSense doesn't tell us that right now. Okie dokie. I still really enjoy those resize now properly. I'm probably going to put one of these messages as a debug. Probably the swap chain out of date 1. This is recreating swap chain out of date. Swap chain suboptimal. Yeah, these are going to be debugs. I'm going to describe what's going on here. Well, we're actually going to change this code in a second anyways, so let's not worry about it too much. Okay, so the next thing we have on our docket is the optional feature that he describes here. This one right here. That's all it takes. I mean, this was actually pretty easy. It was a lot easier than I thought it was going to be. Although we're at 2 hours. So maybe I shouldn't say that. Because that does not feel like 2 hours to me. That feels like 20 minutes. But sorry. Let's try to do this optional feature. So in the swap chain, there is an old swap chain. We want to pass our current swap chain into this function so that it can basically replace the old one. In theory, this means that here, where we're calling this function here, we won't have to return from it anymore. And when the code is multi-threaded, we won't have to, I guess also now, we won't have to wait on the device anymore. So basically we'll be able to get rid of this, and we'll be able to get rid of this return here. And if I look at the way that it's currently running, right, I think one way to demonstrate this benefit is to see if I leave it for a few seconds, right? We're getting about 10,000 frames per second, right? If I take this, and I mean, this is pretty consistent. It slowed down a little bit when I moved it, but it's just pretty consistent 10,000, right? So now if I do this, where it's recreating swap chains all the time. Okay, you know what? It's still getting 10,000 frames per second. So that's not really a good demonstration, I guess. Maybe if I... Yeah, okay. It goes down to 9,000 a little bit. I was trying to see if we could somehow observe that we've improved the code in the future. We'll see if we can get rid of this being 9,000 seconds. I bet if we put like a sleep in there or something, we could definitely observe it. But, I mean, actually, probably what it is it's just the size of what I'm rendering, right? If I make this big. No, that's still the same performance. I don't know where my performance numbers are coming from. Graphics performance is hard, people. So we want to get rid of this and that weight below by basically in here, instead of cleaning up the swap chain, we want to pass it into the existing one. Does he give any advice for this? Because this seems complicated, because there's a lot of things that be going as soon as you've finished using it. So see, that's the part that gets me, because it's like, so I now have to keep track of this old swap chain. I have to make sure that I destruct it properly when it's done being used, right? So let's see if I can find a good example somewhere on the internet. See if we can get an example here. Because we want to, I don't really want to get it off of Reddit. I want somebody, API without secrets, says intel.com. Okay, what do you got for me? This is really early in the, oh, this is a really long page. Okay, let's see if we can find. Okay, describe all of them, but I don't think they provide an example of it. Recreating swap chain. No, they don't. They don't provide an example of how to deal with the old one. Okay, thanks, Intel. Well, okay, so this is the official Vulkan documentation. It's one of their tutorials. So in case you didn't know what we were doing this whole time, this is the Vulkan instance, the driver, right? This is the device, like my graphics card. And then this is the, so the thing that provides the swap chain and the surface that to your screen is actually an extension of the Vulkan API. Like the Vulkan API doesn't know anything about X window managers or any of that stuff. That's all an extension that you get with the SDK. So, but, and then the swap chain is a series of images that you can render too that get put on a surface. Let's see. So they have it, but I don't, you see, the thing is, this is the thing with Vulkan sometimes, is they describe this feature, it's just one variable, right? I just put the old one in there and it just works. But like, there are so many questions I have about how that's going to work that this paragraph is not nearly enough. Okay, let's commit what we have again. And we're gonna take a dive that's gonna crash some things. cleaning up some lifecycle stuff. Okay, let's take a dive into the unknown. Our cleanup swap chain function. See, this is what I'm talking about. These frame buffers and command buffers and pipelines all rely on this swap chain, right? So they take the swap chain image views. I think the command buffers are more problematic. What are the problem? What do the command buffers take here? Or don't they? Or don't they? Huh. Okay, well, this is going to crash. This is totally going to crash. I know this is going to crash. Okay. Okay, yeah, this is going to crash. I have a lot of these functions, huh? Okay, this one's the one I want. So we're going to keep the old one around until we're done with the current one. Well, so no, that's not going to work because now we're just going to get the same resource starvation issue. Okay, so we're going to have the we're going to make it kind of like a linked list almost. So the new one is going to clear the old one's old one. That's what we're going to do. Well, here. I guess probably we should do this later because we don't want to destroy the old one until we know the new one's good. So this is our, okay. All right, we need to put this here. I don't know why that's, and this one's going to have a default value. And then we're going to keep a copy of the old one. Okay, should actually probably call destroy on that. So this actually makes more sense if we do this step first. So basically you can see now that we have this little bit of like a chain structure where we're chaining the old swap chains together. And if there's two of them in a row like this, then we destroy the one that's two older. So now we can take this, go here, do that. Or we only want to do that if this actually exists, right? So what was that before? It was a that. Okay, so do you have a problem with this? Okay, it's just IntelliSense again. Okay, so in theory, it doesn't matter. Scope of that doesn't matter. So let's just make sure this works first before we start deleting any of the threading stuff. I'm going to just see if it causes, you know, resource starvation or whatever. Okay, no, that appears to work properly. Okay, so we got everything good. Okay, so in theory we can delete this. Let's see if our swap chains crash into each other now. Okay, well, I don't actually know if they should be running into each other, so I'm going to leave a comment here for this just in case. And the other thing that I can do is I can come up here and we don't need any of this now. I mean, we need this part because this is the general error. But these parts, well, here, if we hit the VK error out of date, we still do need to create a new one. But we should... So it does say out of date rebuilding, right? So the only issue here is that when we call this, it needs to hit this VK acquire next image again. So we need to like put this in a loop now. In theory, this is actually still running when we hit this here. So I mean, in theory, we fixed it. So maybe we can actually try to see what happens if we don't do this, you know? Like if we comment this out, does this crash? Because in theory, without that device weight there, this is gonna cause like an exception or a validation error at the very least. Okay, well it didn't. It's probably because what we're rendering is too fast. Like we're just rendering, like by the time this gets here from here, it's probably already done. Like because this is all an asynchronous pipeline. Like we're using semaphores to signal every step here. So when I call this submit and this present, I'm not actually I'm not waiting for anything. I'm saying at some point in the future, I want you to present the result of this swap chain. Okay, goodbye. Like I'm not waiting for it to do anything. Like if I had this piece of code here, then I would be waiting for it, right? So that's why in theory, I need this, because I need to wait until the previous swap chain is done. It's possible. Well, when I call this destroy function, right? It's possible that this is not, well, I mean, that's just removing the swap chain. It's not actually destroying the image view, right? So, I mean, it's possible that like this is actually waiting for the thing to finish. Let's check the logs. No validation errors. And the validator is being loaded, right? Like, I guess I've actually shown that log. I guess the thing here is I'm trying to add a feature, and I don't know whether I'm actually doing anything by adding it. So yeah, lunar star standard validation. Sorry, I'm just trying to make sure I'm loading the things that I need to be. Applying device extension. I guess my question is, like, are we actually running the validator? Because this should be triggering the validator. Like, I should not be able to do this without getting an exception or, like, a validation warning of some kind. I mean, the other thing is that maybe the shader is just literally that fast that we're not running into it. So maybe what I need to do is make the shader take longer. I'm not sure how to do that, though. I mean, I guess one thing I could try to do is directly after present, I could try calling destroy to see if it breaks it. But let's make sure that the validator is running first. I think that's the first step here. Okay, so we're saying we want the validation layer. So it says it's supposed to be printing out the layers that we're using, right? So let's see here. Found 6, but we're not applying any of them. Okay, so we may not actually be using the validation layer. That might be the problem. And then the driver or somebody is being nice to us and not crashing everything. Okay, so that's why we're not using it. We're using the wrong name to ask for this. Probably because we're using different versions on Windows and Linux. So we're going to ask for both validation layers. Well, okay. I mean, this is kind of a bizarre thing to try to be programming here, where I'm basically asking it to give me errors. Okay, we're now applying this layer, so that's good. Yeah, applying layer. But let me double check the logs one more time. So it doesn't look like it's showing up in the logs. So I don't know. I mean, this is the sort of thing where it's like, this should definitely be a problem. Like, we should be getting a crash if we do this. So the fact that we're not getting a crash means I'm not sure if we actually did anything by modifying that code. So let's try getting a little extreme here. We're going to take the swapchain destroy function, and we're going to move it up right here. So this is the very next thing we do after we say, hey, we want you to present all the queues and stuff, actually destroy yourself, while it should, in theory, still be running on the graphics card. Not because I want that exception, but I want to see if the validation will actually notice that exception. Well, okay, I guess I should have seen that coming. Now it's always recreating the swap chains because we're always destroying them. But are we not getting a validation error still? We should. Okay, so then I don't even really know if what we just did really helps with anything. But I guess I'm going to keep it. I can't tell if it's actually doing anything, but whatever. Okay. And then we're actually going to pass in the old swap chain. So in theory, that should let us get a few more frames out of it. I'm not sure if that's actually what's going to happen, but okay, well, we're gonna commit that. And I'm probably gonna call that a day. I didn't have anything else with swap chains that I wanted to do. I am probably going to clean up this code some more tonight, but I don't think it's going to be very interesting to anybody. So I was going to cut the stream there at 2.5 hours. I was mostly just going to stream things that are understandable chunks of stuff. So I realized that this may not seem that, but I had like a very specific objective. So I felt like streaming it would be useful because I could always know exactly what the next step was. Whereas a lot of the time when I'm programming, I'm just sort of ambling around and I don't really know what I'm doing like next, like what my goal is at each step. So let's see. What did I want to double check here? So I am using the old swap chain mode here. So good. Okay, we did add that. So I'm going to commit and clean some things up. And I'm going to call that a streaming night. gonna put that on string. And so that's everything. I don't really know how to sign off of one of these, but maybe I'll do this. Boom. It's pretty. Ooh, can I do full screen now? I can't do full screen. Okay, well, that's what's next, I guess, is doing full screen support. What is it? It's doesn't the OS support the full screen mode at some point? Okay, well, I guess I could do that. I could add full screen. I don't know if people are still interested in what I'm doing, but we could try doing that rabbit hole. Oh, one of the other things the guy mentioned was minimization. So if I minimize this, I mean, it's still running, right? That's the problem. No, I lost it, actually. Where's my program? Oh, it's the one without an icon. Okay. I mean, it ran faster when it was minimized. That was nice. I am actually going to call it done. So thanks, everybody, for stopping by. Bye. Okay, I need to time that better in the future. Bye.